So this is the current version of the MATLAB. So with this, we have completed the basic history of the MATLAB. Now we come to the environment setup. So how to set up an environment on your desktop. So setting up a MATLAB environment is a matter of few clicks, and you can download the installer from this given link. So you can download the MATLAB installer from in.mathweb.com, download that download. And it is just matter of few clicks. You will click on the next. You can install the MATLAB from internet or install without using the internet. It takes sometimes like 45 minutes or 1 hour according to the capability of your desktop. And you have just click on the next button and accept the license and terms and conditions. So after that you get a desktop basic that is called a MATLAB window. A desktop basic or MATLAB window have 4 major parts. First part is called as the current directory. Second part is the workspace. Third is the command window. And fourth one is the command history. So when you open the MATLAB, you will get 4 different parts. That is current directory, command window, workspace, and command history. So first we discuss about the current directory or current folder. This panel allows you to access the projects, folder, and file. So this folder shows the directory where you will save your current file. So if you write a script and save the script, it will be saved in this current folder. You can change the path of folder according to your requirement. You can save the script in D drive, and so on. Second one is a command window. This is the main area where commands can be entered at the command line. It is indicated by the command prompt that is 2 less than singular. So this is the command window. So I will share the link to download the MATLAB in chat box. So second one is the workspace. The workspace show all the variable created and or imported from the file. So when you are writing a program, there is 2 things. One is the constant that have a value always fixed, and second one is a variable that have value change during the program execution. So when you create a program, you create multiple variables, and these variables are shown in workspace. So the workspace shows all the variable created and are imported from the file. Second one is the command. Fourth one is the command history. This is the panel showed or return the commands that are entered at command line. So it will provide the command history. You have write any command in command window, so it will be shown in a command history. So with this, I will also show the environment of live environment of the MATLAB. So this is the live environment of the MATLAB. Is my screen visible? Okay. So, this is the current folder. This is command window. This is workspace, and this is the command history. Now this is the home button where you can start a new script. You can create a new document. You can open already written script or old script. You can import data. You can save the workspace for later use. You can create a new variable. You can open the already available variable. You can clear the workspace. Here are some analyzing the code. If you want to debug the code, you can use the analyze code button. This is for run. If you want to run your command, you can click here to run the written command. And this is for clear the command. And this button for the Simulink library. In Simulink, you get some symbolic pattern for the particular operation in MATLAB. So second button is for plots, where you can see the multiple plots, different type of plots, like this is a 2D plot, this is, and when you take a cursor on this section, it will show the all about this plot, all description of the this function. It will give the whole description of the function. So there I have a bar graph, area graph, pie graph, histogram, contour graph, and different type of, you can create different graph according to your requirement. And next is the app, that is show the different type of application. For example, there is a application for curve fitting, optimization, signal analysis, image acquisition, simulation biology, MATLAB coder, MATLAB compiler, or there are multiple. If you click here, there are multiple applications. For example, these applications are for math, statistics, and optimization. These applications are for the control system design and analysis. These applications are for the signal processing and communication, and these are for image processing. Similarly, for test and measurement, for computational biology, and so on. There have a lot of applications that are required for the different area of the research in engineering and science. So this is the basic window environment, we can say the desktop window for the MATLAB. So now we come to the MATLAB package. So package are special folder. We can see the toolbox where we have stored some bulletin function, can contain the class of folder, function, class definition file, and other package. So the name of classes and function are spoke to the package folder. So when you created a class, when you create, there are some multiple inbuilt functions. These functions are saved in the package, in different type of package. And these packages are used according to your requirement. For example, if you are talking about the vision computer, they have a different package. If you are talking about the mathematics and statistics, they have a different type of package. And a package is a namespace within which name must be unique, and each package have a unique name in MATLAB. But the function and class name must be unique only within the package. Okay, so the function and class have a same name within a particular package. So if you want to see the version of MATLAB as well as the list of all toolbox or packages, you can write VER. You can simple write VER in your command prompts. So in command window, I write VER and press enter. So I get all description about the toolbox and packages available in MATLAB. So this is a MATLAB version 8.1, and this is for Microsoft Windows 8 operating system. So there is a Simulink, there is a aerospace block set for aerospace engineering. There is a bioinformatics toolbox for the bioinformatics. There is a communication system toolbox for the communication engineering. There is a computer vision system toolbox for the computer vision and machine learning. There have a curve fitting. There have a filter design, and so on. Multiple packages or toolbox available in MATLAB. So if you install a MATLAB and you want to check how many built-in function in or package in my MATLAB, you just write VER in command window, and you get all the list of available toolbox in your MATLAB version. So if you are working in mathematics, so there is a toolbox that is called as a statistics toolbox. So it provides the whole type of function like median, mode, anything you want to calculate. All functions are available with this toolbox. So now we come to the MATLAB library. So a block library is a collection of blocks that you can use in simulink model. So MATLAB also provides a graphical user interface where you create some blocks to write a program, and these blocks are called as a the collection of these blocks called as a library. So you can create instance of blocks from the built-in Simulink library, and you can make custom libraries for the instance of block that you create. You can access the built-in library from the Simulink library browser. To view the block library for the product you have installed, type Simulink. Just type Simulink in MATLAB prompt to get all the available library blocks in your MATLAB package. So, for example, I write Simulink and press the enter. It will take some time. It will take some time. So you have to wait for this. It will take 1 or 2 minutes to open the window for Simulink. So when you get the library of Simulink, it will be shown. So there are multiple packages such as for open the library for communication toolbox. It will provide the different blocks for the channels, filters, integration, error detection and correction, and unitary blocks and so on. You can get multiple blocks. So this is the Simulink library browser. So here you can see some commonly used blocks for discrete signal, for continuous signal, for lookup tables, for signal routing, and so on. Now, if you check the blocks for the aerospace, so click here. If you want to check the blocks for fuzzy logic toolbox, then click here. If you want to check the for vision and computing, you will click on the vision and computing. So there are a different type of. So for example, if I click here, then I can get a function that will create that will get the video from your desktop or your device. So there are multiple blocks. These are called as a MATLAB library. So like in commonly used, if I just click on the commonly used blocks. So if you want to create a bus creator, you select this symbol. If you want to show the ground, then select this symbol. So these blocks are useful in electrical and electronics engineering. So just wait. So if you are want to create a 3D animation in mechanical engineering, you will click on the Simulink 3D animation. So here you can select the different available modules for the different animations. So these are called as a library. So it depends on your area of research, your area of study, and according to that you can select any required blocks. First you select required toolbox, then you select the required blocks to create a graphical program. Okay. So these are called as a MATLAB library. So now we come to the using the MATLAB as a calculator. So first, how to use the MATLAB as a calculator. So if you want to use a MATLAB as a calculator, you just write your mathematical expression and press enter. Or you can click on the execute button, or you can type Ctrl-E, and MATLAB execute and immediately give the result of your mathematical expression. function. For example, if you write sine pi by 2, it will give the value of sine. So I demonstrate it. So I write 3 plus 4. It will give the answer f. Okay. Now I write 5, 3. It will give 125. Now if I write sine pi by 2 and press enter, it will give the value of sine. So without any initialization, without any creating variable, without any writing particular statement, you just write your mathematical expression and press enter, you will get the results. So any doubt in this section?
Hello.
Hi.
I want to ask one thing.
Yes.
So what is the obvious argument for trigonometric function? These are means of radians or degree argument.
You can use the radian argument, and you can also convert these into particular degree to radian, radian to degree. Okay. I will see different type of function in upcoming slides.
Okay.
Okay. So if you write 7 by 0, you divide 0 with 0 to any number, it will give infinite. So we execute. If I write, for example, 5 divided by 0, it will give INF. That is for infinite. So as we know, when we are talking about some programming, so we have create some variable. Okay. So here are two things. First one is a constant, and second one is a variable. Constant have the value is always fixed. It does not change during the program execution. But the variable have the value change during the execution. So once a variable is entered into system, you can refer to it later. So when you create a variable, you can use this variable in upcoming statement. The variable must have value before they are used. So you have to initialize the variable before using these variables. When an expression returns a result that is not assigned to any variable, the system assigns it to variable name A and F, which can be used later. So for example, if you write a particular mathematical expression and run this expression, the value of resultant value or output of this expression is stored in a system generated variable that is named as A and F, and you can use this variable in future. So what is the difference between C language and MATLAB or C++ and MATLAB? So you do not have to declare type. So when we writing a program in C language, we write in a float, a text array. So you do not require any type declaration. So do not even have to initialize, and you just write like A equal to 12. So it create a variable A, and the initial value of the variable A will be 12. So this is called as a MATLAB prompt. The equal signal is the assignment operator that assigns the left hand value to the right hand variable. This is semicolon. That is called as a suppress command output. We will discuss about the semicolon in upcoming slides. And this is comment operator. We will also see what is the comment. So this is name of the variable. This is the MATLAB promote. This is the name of variable. This is assignment operator. This is the value which we want to assign to the variable. This is suppress command output, and this is comment operator. So how to create multiple variables within a single statement? So in MATLAB, you can have multiple assignment on a same line. For example, if you write a equal to 2, b equal to 7, c equal to a cross b, it will be executed. For example, first I write x equal to 5. So it will give the output x equal to 5, and in workspace it creates a variable x. And when you double click on this variable, it will give the all information about this variable. So this variable, in type of this variable is double. It is 1 into 1 cross 1 matrix. Okay, 1 cross 1 matrix. So you can check the all information about the variable by double clicking on the variable that's shown in workspace. Now, if I want to write multiple variables in a single line, for example, I write x equal to 4, y equal to 7, and z equal to x plus y, and press enter. So it will give 7 plus 4 is 11, and it creates these three variables x, y, and z. And the value of x is 4, the value of y is 7, the value of z is 11. So now we come to the use of semicolon. So when we are talking about the C language statement, we use the semicolon to end the statement, but here is another purpose in MATLAB. So when we use the semicolon, it will not show your output on the command window. So semicolon indicates the end of statement. However, if you want to suppress and hide the MATLAB output for an expression, add a semicolon after the expression. For example, if I write x equal to 7, okay, and y equal to 8, so it only shows the value of y. It will not show the value of x in the output. So by using semicolon, you can hide the output in command window. Now, when we are writing a very large program, there have a multiple number of the variable, and sometimes we have forgotten the variable. So how can we find the list of variables? So there are two options. One command is who command will display all the variable names you have used, and if you use command who, it will give the complete information about the all variables. Okay, so we try. We first write two. So two variable are ANS, X, Y, and Z. You can verify from the workspace. So there are four variables ANS, X, Y, and Z. And if I write good and press enter, it gives the all information about the variable. So there are four variables ANS, X, Y, and Z, and we see the size of each variable, how many bytes it required, and what is the data type of the variable. So now we adding the comment. So if you want to write a particular line which should not be a part of your program or your script, it is called as a comment. The percent symbol is used to indicate a comment line. For example, if you write x equal to 9, then percent assign the value 9 to x. Then it will only run the x equal to 9. It will not execute this statement. And if you can ask, if you want to use a multi-line command, or you want to write a block of command, so you can use a block command operator that is start with percentage curly braces, then you write your text, and it is ended with the percentage and curly braces. So you can see I have write z equal to 7. Okay. Then I write percentage is age work show. And I press enter. It will only give the output of this command, that is get equal to 7. It will show only 7. It will not show this command. So this is a single line in MATLAB. And if you want to multi-line command, you can use percentage curly braces, then you write your text and it will be closed with percentage curly braces. Now we come to the command for managing a session. If you want to manage a session that you are writing a particular, you can think about if you are a student of mathematics or statistics and you have calculated some value and write on your copy, and after that you have to remove these all equations or calculations from the command window. So you can manage the session with some command. Here I have a lot of command. I will not be able to explain the whole command in this short time of period. So here I will explain only the major commands that have been used for managing a particular session. So if I write CLC, so this is a clear command window. If you want to clear the command window, you write CLC. If you want to remove the variable from the memory, you want to clear the workspace, you will just write LEAR, clear. If you write exist, it will check the existence of a particular variable or file. If you want to declare a particular variable and a global variable, you just write global before assigning the variable. If you want to the very fantastic feature of the MATLAB is that you have not to remember any command. You just practice, you will remember some command and then you will just use a help command to check see the any we can say the syntax of any command. You just write help and you get all information about the any bulletin function. You can also use look for. If you want to stop the MATLAB, you can write it. Here is a who. It will show the list of current variable. Here is a WHOS. It will give the list of current variable with all descriptions. If you want to change the directory, you can use CD or you can direct use by graphical user interface. You can write, if you display the current date, you write dates. If you want to delete a particular file, you write delete. If you want to load a workstation variable that you have already saved in your directory, you use load. You want to display path, you can save, you can display the type of content, you can list the MATLAB file in current directory. So there are a lot of commands that have been used to manage the current session. So for example, if I write CLC, it will clear the command window. It will clear the command window. Now you can see there are 4 variables in workspace, and if you want to clear these variables, you just write CLEAR, clear. It will clear the all variable. If you write date, it will show the today's date, that is 24 May 2021. Now sometimes we will confuse how to remove the command history. Would you just select any line, then press Control All, Control A, it will select the all statement in command history. Then by right clicking, you can delete this session. You can delete this session. It will delete all the command history. So there are multiple commands. You can use the command for different type of the purpose. Now we come to some input and output commands. So there is a diff command that display the content of array or string. If you want to display the content of array or a matrix or a vector, you can use this. There is a fscan app. If you want to read data from a particular file, you can use fscanf. There is a format. There is a command that is format. If you want to control the format of particular variable, you can use format. There is a fprintf. If you perform formatted writes to screen or a file, if you want to show the output in your command window, you can write fprintf. There is an input that display if you want to take data from your keyboard. So in C language, we use the scanf function. Similarly, here we use the input function, and it display the prompt and wait for the input. When you press give the input, it will execute the next statement. This is semicolon that suppress the screen printing, and there have a different format code. For example, if you want to show the string, you write %L. If you show the integer, you write %D. For floating, %F. For if you want to new line, there is a %N. If you insert a tag in output string, you write \T. We will see these commands in when we will discuss about one or two examples. Then we will discuss about these commands. So now we come to the operator. We know when we write any arithmetical expression, there have two parts. One is the operator and second one is the operand. So for example, if I write A plus B, so A and B are the operand and plus is a operator. So operator tells the interpreter what is the operation we have to perform on the variable or data. So in MATLAB, a large number of operators can be used. Here we will see some basic operator, and we will execute the operator in upcoming slides. So plus is for the addition operator, minus is for the subtraction. This is for the scalar multiplication and matrix multiplication. Dot star is for the array multiplication. If you want to multiply element by element multiply, you write the dot star. This is for the scalar and matrix exponential operator. This is for array exponential operator. This is for used for left division operator. This is used for right division operator. This is for the array left division. This is dot slash is used for array right division. So this is a colon operator. So we can use the different brackets. We can use point as a decimal. If we write 3 point, if they have a very long expression, or we can say a very long statement, you can use the 3 dots and continuing new line. This is comma, semicolon, percentage symbol that you use for comment. We have already seen about the semicolon and percentage symbol. This is for the transport of operator. This is non-conjugate transport operator. This is the assignment operator. So there are multiple operators that can be used in MATLAB. So MATLAB also offers many predefined mathematical functions that is used for technical computing, which contain a large set of mathematical functions. For example, or if you want to calculate the cosine value of any variable, you write cos x. So this x may be any number. For example, you write x vary from 0 to pi by 2 and plot this value. So it will plot the graph for the cos x. So x is 0, then automatically it will in increasing order to up to pi by 2. So for sine there is a sine, tan, exponential, ext. For square root there is a sqrt. For log base 10. For absolute value there is a abs. For if you want to find a maximum value from a set of array, you can write max. If you want to get the minimum value, you write min. If you want to float, ceiling, if you round to nearest integer to any variable x, if you want want to find the remainder after division, you write REN. There is a angle that if there is a complex number and you want to find the phase angle, you just use angle. If you want to find the complex conjugate, you just use UNG function. So there are multiple functions, and in this short period, I can not demonstrate all these functions. You have to write these function in your command window and try all these type of functions. So, for example, I have a variable that is x equal to 5. Now I write cos x. It will give the value that is -1. Now the question from one student, that is, if I write y equal to 7 and I write cos y, it will give the value. So you can put the value in a radian, or you can put a simple integer and input for a trigonometric function. So now we come to the next slide, that is the mathematical function. So in addition to elementary function, MATLAB have a number of predefined constant values. So if you want to write a pi, you just write pi. For eta, you can write I for imaginary unit, that is the square root of -1. You just write eta. For infinite, you write I in capital and in small and f in small. I and f for the infinity, and NaN, not a number. If there is a null value, you can write NaN. Now, if you want to calculate this value in MATLAB, for example, you want to calculate the expression that is y equal to e raised to power minus a sin x plus tan square root y, and there is a given value of the a and x and y. You just write a equal to 5, x equal to 2, y equal to 8. Now you write y equal to exp. This is for exponential because there is a e raised to power minus 8. So I write exp. In bracket there is a minus a. Now into sin x. So I just write sin x plus there is a tan root y. So tan into FQRT y. So y is equal to, it will calculate the value of y. So by using these built-in functions and variable, you can write any mathematical expression in command window. So now I come to the M file. So you can write your MATLAB code in your command window, or you can write a MATLAB script that will be saved as a .m file. So I think there are only 30 minutes remaining, so I will complete it in fast. Or if you allow me, then I will complete the all content within 1 hour.
Take time, sir.
Okay. Okay. So now we come to the M file. So if you have a small program, you can write direct the command statement in command window. But if you have large program, you want to make a larger big program, you have to write a script. So for this, you just click on new script. You just click on new script. When you click, editor will be shown. Anji?
Sorry for interrupting, sir. One question I want to ask.
Okay.
In previous slide, you write x equal to pi.
Okay.
Then you calculate cos x.
Yes.
Pi x equal to pi gives us 3.1416.
Yes.
But if we write cos of 3.1416, then maybe there will present some error. Since we know cos pi equal to minus
cos pi
equal to -1. We all know that.
Yes.
But
So
if we type, yes, sir.
Okay, you are saying if I write 3.14 and then I write cos x, it
No,
will
sir.
be the
No, sir. What I want to say, x equal to pi.
x equal to pi. Okay.
This will give value 3.146, right? And
Okay.
now if we calculate cos x and cos 3.1416, then
X. Okay.
this will
Okay. You are telling, so if you are saying if I write cos 3.414, it will give the error. Because
Yes.
it will function that will take only the variable as input.
Error in the sense that means in first answer it gives -1, but in another answer it will give minus of 0.9999 something.
Oh, it will give it -1. You can see.
And now use the command VPA answer. VPA.
Okay.
Small bracket ANS. That's also. Yeah, that was.
Actually, hello.
Yes, sir.
Yes, sir.
Yes, sir. Can I tell about this?
Yes, sir. Yes, sir. Please.
VPA stands for very precision answer, and that is giving us accuracy up to so many digits. While here it is rounding off. Okay.
Yeah, yes, sir.
The value of pi we have not taken exactly. It is this number. So we have taken up to 4-digit accuracy. So it will not give the correctly. VPA will not give us correctly -1. Whatever value of pi you take, no, up to 32 digits accuracy you will take. Then also VPA will not give you -1 cause of that. This is because very precision, and while that directly cause of that, it is giving us the rounded off of 4 or 6 digit accuracy.
Okay, thank you, sir. Now we come to the .m file. Okay, now sir, welcome, sir. It is very useful for me. I have no information about VPA because I am from the computer science background and working in the quantum cryptography. So it is very useful for me. In upcoming, we will do any project in MATLAB, then it will be useful for me. So now we come to the M file, that is extension of the MATLAB script. If you want to write a large program, so you cannot use the command window directly. You have to write the program in your editor. So when you click on the new script, it will open. So you can write here any program. So for example, I write A equal to 5. B equal to 4 and C equal to E raised to power 2 plus E raised to power 2. So now we have to save this file. So I have given it name. So now you can run this file from this button. And when you click on this button, it will give run if the path is set. If there is a different folder, you have to change the folder. Either you can add to the path. Now the result will be in the command window. So if you want to write a big program, you have to write a MATLAB script. You cannot use the command window direct for the big application. So this is called as a emph. So now we come to the arithmetical operators. So MATLAB allows two different types of arithmetical operations. First is the matrix arithmetical operation, and second one is the array arithmetic operation. So the matrix arithmetic operation are same as defined in linear algebra, and array operation are executed element by element. So if you direct multiply the matrix, it will be the simple linear algebra matrix multiplication. But if you execute the arithmetical operation in array, then it will be a element by element operation. The matrix operator and array operators are differentiated by the period symbol dot. So if you use simple multiplication symbol, it will be a simple multiplication. But if you write dot star, it is a element wise multiplication. So as the addition and subtraction operation is same for the matrix and array, the operator is same for both cases. And if we want to perform some addition or subtraction of the matrix or array, there will be no requirement of the period symbol. So now we come to the arithmetical operators. So because the organization committee have been told me that you have to design a very basic lecture, because most of the students are not aware with the MATLAB and programming. So that's why I have created a very simple presentation, and I have demonstrating very simple way. So there are arithmetical operations. For example, you have a variable that have a value a equal to 10 and b equal to 20, and if you write c equal to a plus b, it will give the summation of variable a and b. If you write a minus b, it will give the subtraction of a and b. If you write a multiplication b, it will give the multiplication of the variable. And if you write a divided by b, so a will be divided by b. This is the right division. So means b is divided by a. So this is a variable assignment, and here to write x raised to power y. So these are the output. So when you perform addition, it will give the 10 plus 20, that is 30. When you write a minus b, it will give the 10 minus 20, that is minus 10. So there is a 200. When you divide 20 with 10 with 20, it will give the 0.5, and when you divide 20 with 10, it will give the 2, and this is the exponential. So these are the simple operations, so no need to demonstrate these arithmetical operators, I think. So there are some functions for the arithmetical operation. First one is the u plus, that is the array plus. If you want to increment by the amount a, you can use u plus function. If you want to perform the addition of a and b variable, you just write plus a comma b. If you want to ordinary minus, this decrement by the amount a, you just write 2 minus a. If you perform the minus of a and b, you just write minus a comma b, that is a minus b. If you want to multiply the array element, you just write times ab. It will give the element wise element multiplication of the array. Some people saying my screen is not visible. My screen is visible.
Yes, sir, it's visible.
Okay. So it may be a problem with the website. So if we write m times a comma b, it is a matrix multiplication of a with b. So there is a two matrix a and b. If we want to multiply these matrix, so we write m times a comma b. Now if you are working on the conditional operators, you want to make a particular statement based on the decisions, so you use the relational operators. So there is a multiple relational operators. First one is a less than operator, that is less than equal to operator, greater than operator, greater than equal to operator, equal to operator, and not equal to operator. So if you want to compare two quantity, or you want to compare two variable, and based on the condition you want to run particular statement, you will use these relational operators. Now we come to the vectors. So the vector is a one-dimensional array of the numbers. So it is a one-dimensional array. It's called as a vector. And MATLAB allows to create two types of vector. You can create the row vector, you can create a column vector. So if you just write name of the vector, then assignment symbol, then a square bracket, and then write the element with space or comma, it will create a row vector. So for example, you write r equal to square bracket, then first element 7, then space, second element, then space, third element, then fourth element, then fifth element. It will give the resultant value 7, 8, 9, 10, 11. This is the array of, or a vector of size 5. Vector of size 5. This is a row vector. So if you want to create a column vector, you can create a column vector. So the syntax is same. You just use the semicolon in place of the comma or space. So you just write c equal to 7 semicolon 8 semicolon 9 semicolon 10. It will create a column vector of the size 5. Now we come to the indexing of a vector. How we can access the element of a vector. So there are several ways to access the element of a vector. For example, if you write a vector b, it have a total 6 elements, 1, 2, 3, 4, 5, 6. Now the indexing of this variable is this vector is start from 1, 2, 3, 4, 5, and 6. So the vector will be start from the vector indexing will be start from the 1. So if you write B3, it will give the value of a third element. So this is the first element, this is the second element, this is the third element. It will give the output of third element. And if you write B colon, it will give the all elements. It will give the all elements. Now if you want to create a sub-array, or you want to create a sub-vector, you just write the starting index and then ending index. You just write starting index and the ending index. It will give the value of this sub-array. Now for the student who are very new in MATLAB, so we write. So if I want to make a vector, so first I clear the workspace. So if x equal to 2, 3, 5, 4, 8. So when I press enter, there is a vector of size 5. You can check here. So it is a variable of 1 into 5. So every variable, every vector, every matrix is represented in a two-dimensional vector space in MATLAB. So this is the array of size 5, that is 1 to 5. So if I write x 2, sorry, the MATLAB is a case sensitive, so x equal to 2, it will give the value 3 because the second element is a 3. If I write x colon, it will give the complete vector. It will show the elements of the complete vector. Now I write x 2 4. This colon. Okay. I have given the mistake in my command. So if I write x colon, so that is equal to 3 5 4. So it will give the element from index 2 to index 4. So similarly, you can access the column vector also. So there are multiple operations we can implement on the vector. We can perform the addition, subtraction, scalar multiplication, transpose of the vector, appending to vectors. We can find the magnitude of a vector. We can perform a dot product of the different vectors. So we will see one by one each operations. So first I have created a vector 7, 5, 4, 11. Then I have created another vector that is 6, 3, 2, 9. And now I perform C equal to A plus B. So it will add the two vectors. So 7 plus 6 is 13, 5 plus 3 is 8, 4 plus 2 is 6. If I write E equal to A minus B, now it will not show anything. So if you want to see, you just write DISP and then D. So it is the minus of A minus B. So 7 minus 6 is 1, 5 minus 3 is 2, and so on. So by using direct plus and minus, you can perform the different arithmetical operation. Now if you want to perform a scalar multiplication, so for example I write 4 multiply D. So it will give the scalar multiplication with the vector. So 4 into 1 multiply with 1 is 4, or multiply with 2 is 8, it's 8. Now if you want to create the transpose of a vector, for example I want to get the transpose of a vector A, you just write A and this symbol. So it will give the change the row vector into the column vector. Now if you write E equal to A comma B, it will combine or concatenate the array A and B, vector A and B, as row wise. And if you write F equal to A, then semicolon, then B, it will create a matrix of 2 row and 2 into 4 by matrix. Now if you want to find the magnitude of any vector, for example I write a vector B equal to 2, 3, 5. This is a vector. So I just write F B equal to B dot star B. Now B equal to sum X B. Now M equal to SQRT EP. So it will give the magnitude. First we have a vector that have a value 2, 3, and 5. We perform the dot operation, dot multiplication, or we can say the element by the element multiplication 2. So it will give the 2 into 2, 4, 3 into 3, 9, and 5 into 5, 25. Then we perform the summation of the value. So the 4 will be summed with 9 and 9 will be summed with 25. And then we get the SQRT, under root of the resultant value, and it will give the magnitude of the. So if we have one matrix that is 2, 3, and second vector that is equal to 4, 5. And if we want to get the dot product, just write dp equal to dot v1, v2. It will give the dot product of the vectors. So now we come to the matrix. So with this we have completed the different operation on the vector. Now we come to the matrix. So matrix is a two-dimensional array of the number. In MATLAB you create a matrix by entering the element in each row, adding comma, a space, and delimited number, and using semicolon to mark the end of each row. For example, if you want to create a matrix of the 4 by 5, you just write first row. So this is the value for the first row, 1, 2, 3, 4, 5. Then here the row is completed, so you have to use the semicolon. Now second row, 2, 3, 4, 5, 6. Now this row is completed, you have used the semicolon. Now the element of third row, 3, 4, 5, 6, 7. Now you have used the semicolon. And again the fourth row, that is 4, 5, 6, 7, 8. So when you execute this statement, it will give a matrix that is it will give this matrix. Okay, so you can create the matrix by using this expression. So if you want to referencing the element in of a matrix, to reference a element in mth row and nth column, you just write the name of matrix and then number of row and number of column. If you want to find the element of mth row and nth column, you just write the name of matrix, then small bracket, and the row number, comma, column, and you will get the element at this position. For example, if you want to find the element of second and row and fifth column, you just write A to 5. So this is the second row, and this is the fifth column. So it will give the result 6. So if you use colon, comma, m, it will give the all element of the mth column. It will give the all element of the mth column. So for example, this is we have created a matrix in which there are the first row, that is second row, that is third row, that is fourth row, and I write colon 4. This means it will give the value of the fourth number column. It will give 4, 5, 6, and 7. It will give 4, 5, 6, and 7. You can also select the element in mth to nth column. For this, you can write A colon M colon N. So if you want to get the element of second column and third column, you can write A colon 2 colon 3. So it will give the value of the second number column and third number column. So in matrix, you can also perform the different operation. So you can add and subtract to matrix. You can division of the matrix. You can perform the scalar operation of the matrix like scalar multiplication. You can get the transpose of the matrix. You can concatenation of the two matrix. You can perform the multiplication of the two matrix. You can also get the determinant of the matrix. You can also perform the inverse of a matrix. So if you write A, comma, it will give the transpose. If you write B into A, it will give the multiplication of the matrix B with A. If you write B, comma, star A, it will give the element by element multiplication. If you write B divided by A, it will give the B multiplication of A inverse. Multiplication of A inverse. It will give the that. And if you write B dot then divide A, it will provide the element wise element division. If you write B A, it will join the matrix horizontally. If you write B semicolon A, it will join the matrix vertically. So sum of operation we can see in MATLAB. So for example, I have a matrix A that is equal to 1 space 2 space 3 then semicolon 4 5 6 then semicolon 7 8 9. So it will give a matrix of 3 by 3 and the element first row is 1 2 3, second row is 4 5 6, third row is 7 8 9. Now you create another matrix that is 7 5 6 colon 2 0 8 colon 5 7 1. So it will give the another matrix that is a B matrix that is first row is 7 5 6, second row is 2 0 8 and third row is 5 7 1. Now if I perform A C equal to A plus B, so it will give a 3 by 3 matrix that is the element wise addition of the matrix. So 7 plus 1 is 8, 2 plus 5 is 7, and then the 5 plus 0 is 5 and so on. Now if you want to get the transpose of this matrix, you just write C and it will give the transpose of the matrix. It will give the transpose of the matrix. If you write C A comma B, it will give a matrix that will be a horizontally allocated of the A and B. And if you write C equal to A colon B, it will give a allocation of the vertical. Vertical allocation will be given. So if you want to get the determinant of a matrix, you just write for example x equal to DET of A. It will give the determinant of a matrix A. So you can also find the inverse of any matrix. So if you want to find the inverse of any matrix, you just write INV. It will give the inverse of the matrix. So by using these different type of the operations, you can perform the matrix calculation. So now we come to the array. So all variable of all data type in MATLAB are the multi-dimensional array. A vector is a one-dimensional array and a matrix is a two-dimensional array. So if sometime we want to create a some particular array, so there are a multiple function. If you write zeros and then give the size of matrix, it will create a square matrix of 5 by 5 and all elements will be 0. There is another function that is called ones. So if you write ones 4, 3, it will create a matrix of size 4 by 3 with 4 row and 3 column and all elements will be create an identity matrix, you just write E by. So if you write E by E4, it will create a 4 by 4 matrix, and the element of the diagonal will be 1. So if you creating any random matrix, so if you sometimes we perform an encryption of the images, so we have required a random matrix. So you can use the rand function, RAND rand function. You write the number of rows and column. If you write RAND 3, 5, it will create a 3 row and a 5 column. This matrix will be a random matrix. There is another function that is a magic. The magic function create a magic square array, takes singular argument that gives the size of square. The argument must be a scalar and greater than equal to 3. So if I write magic 4, it will create a matrix of 4 by 4. So an array having more than 2 dimensions is called a multi-dimensional array. In MATLAB, you can also create a multi-dimensional array. So how you can create a multi-dimensional array? For example, if you write A 795 colon 619 colon 532, it will create a 3 by 3 array, or we can say 3 by 3 matrix. Now, if you want to provide another dimension, you just write name of array, colon for the row, colon for the column, and then you write 2 and give the value. So when you print E colon, comma, colon, comma 1, it will give the this matrix. It will give the this matrix, a multi-dimensional array. And if you write A colon, comma, colon 2, then it will give the this array. So you can create a multi-dimensional array in the MATLAB. So if you want to sort an array, so you just write a vector, and there is a function that is sort, S-O-R-T. You write sort B. It will give the ascending order of the array. It will give the sort in the ascending order. Now, if you want to array the matrix, sort the matrix, you just write a matrix and write sort M, 1. It will sort the matrix along with the rows. And if you write short M, 2, it will short M along with the column. So if I write A equal to 2, 3, 1, 5, 4, 6, this is a vector. Now if I write short A, it will give the sorted array in ascending order, 1, 2, 3, 4, 5, 6. And if you want to get the descending order, you just write short A, comma, then you write the descent, and it will give the descending array. So if you want to sort the matrix, so you just write M equal to 1, 2, 4, 3, colon 6, 2, 3, 7, 4, 1, 4, 6, 1, 2. Now this is a matrix of 3 by 4. Now if you write short and comma 1, so it will short it as a column wise. So this is a 163. So in output there is a 136. Here is a 226. Here is a 226. Here is a 431. But the output is a 134. So column wise shorting. Now if you write short M, comma 2, so it will short in the row wise. So 1, 2, 3, 4. Okay. So this is the original matrix. So 1, 2, 3, 4. Now it will be 2, 3, 6, 7. 2, 3, 6, 7. Now it is 3, 6, 1, 2. The output is a 1, 2, 3, 6. So by using these things, you can short any matrix or array. Now we come to the function in M file. So you can create a function file. As we have seen C language, we can create a user-defined function and call the user-defined function by giving the arguments the function. So format of this function is write function, then write the output argument. There are multiple arguments you write in brackets. Just write the output argument. Then you write the name of function, and here you write the input argument. Here you write the input argument. So we create a file. Function E equal to A, comma B. Now E is equal to E square 2 plus B square 2. Now we have created a function. The name of function is a param. The input arguments are A and B. The output argument is a C. So you have to save this function in the name of if you have declared the name of function in the same name, you have to save the file. You have saved this file. So when I write param comma 2 comma 3, and then it will give the output, that is 13. Because 2 raised to power 2 is 4, 3 raised to power 3 is 9, and 9 plus 4 is 13. Here I have called the function. So every function have a different parts. So here you write a function that is a keyword. So if you want to describe the function, so you can write the comments for the help. So these are the help lines for the function. This is the name of the function. The name of the function should be same as you save the file. So this is the input argument and this is the statement block. Make sure you save change to the M file before you call the function, and before calling the function you have to save the file. These are the different parts if you want to create a user-defined function M file. Now we come to the decision making. So if you want to create a program based on the decision making, so you first check the condition by using the if statement. Now if statement is true, it will run this conditional code, and if the statement is false, it will directly come to here. And if you use the if else statement, you check the condition here. If the condition is true, it will run the code of if under the if block, and if the condition is false, it will run the code under the else block and give the output. So this is the decision making. So I think it will also be in the be a part of next lecture for the another expert. So we will see here brief. So here A is equal to 100. If A is less than 20, so F print A is less than 20. Else F print A is not less than 20. And here I print the value of A. So because the A value of A is 100, so the first condition, that is the if condition, is false, so it will go to the else condition and it will run A is not less than 20 and the value of A is 20. So now we write a small script regarding to text. So I have write it A equal to str to double input first number. Age less than B F range F large number age equal to percentage D dash N comma B else end. So here I have write first is the input statement, that is input. Here I write a message that I input the first number and it will always take the data in a string value. So here I write the S, and because we are checking the two numbers, so I have converted the string into double. So this is a function that converts the string into double. So similarly I have write a statement for the second number, and then I check if A is less than B, then printf large number is a B, else printf large number is a B. So now I save this program. Now I run this program. So run this program. So it gives the message that it input first number. So I press 5, then I give the second number. So the output is large number is equal to 8. So by using this conditional statement, we have created a program to find the maximum number among between the two given numbers A and B. So with this I have completed the basics of MATLAB package, and about the grouping, conditional statement, graphic, plottings, and after that about the statistics and different functions of the mathematical operations and data analysis will be covered in upcoming lectures. So thank you to the organization committee to give me the opportunity in this workshop. Thank you again.
Thank you so much, sir. Dear participants, any queries? You can ask your questions from our keynote speaker, Dr. Parvinder Singh, if you have any.
Some people tell me that I should share the PPT, so I will share the PPT with two people. So please provide me the email address. So I will share the PPT.
So please send the PPT to mail, sir.
Okay. I will send the PPT on mail from my get the invitation.
Yes, sir. May sir will provide to everyone. Will provide to every participant. Okay, thank you, sir.
Thank you.
Excuse me.
I would request.
I want to ask a question to Dr. Parvinder Singh.
Yes, sir.
We always work in three-dimensional space in a real life or in any tools or software that we use regularly. I am working on a field which is in four-dimensional. So I want to ask that is there any tool or software by which we can draw a four-dimensional space of shape? Is there any software?
Yes, it depends on your application. For example, when we are talking about the quantum mechanics, because I am working in the quantum computing, so there are sometimes we are creating the four-dimensional graphs related to the correlation and entanglement, and we are basically use the Mathematica. I think Mathematica is more easy than the MATLAB for creating and plotting the different graphs, in my view.
So means by using Mathematica we can draw 4D diagrams or graphs.
Yes, you can create the 4D graph by using the contour graph and subs graph. Even you can create the multi-dimensional, 5-dimensional graph you can create in Mathematica. That will give the 3-dimensional structure and give the 4-dimension to particular color, and according to change in color, that will be show the dimension of 4th dimension. There is also options in MATLAB is also available options you can create, but I think if you want to create the 4 or 5-dimension graph very easy method, you can use the Mathematica. And if you want to find a particular file, you can connect me on my email. I will give a example of 4D graph.
Sir, I am asking what your email and what about that.
Okay. So I write my email in chat box.
Okay, sir. Thank you, sir.
Thank you.
Thank you, sir. Dr. Mayer sir has already shared your certificate. Thank you so much, Dr. Parvinder Singh sir, for such an informative session on the history, environment setup, and basics of MATLAB. Dr. Parvinder Singh has taught the beginners of MATLAB to create variables and perform arithmetic operations on these variables. Now, everyone who is joined in this workshop knows how to work on functions, vectors, matrices, and arrays and conditional statements in MATLAB. Dr. Parvinder Singh sir, it's an honor to share space with you even if it's virtual. We hope to maintain this collaboration for years to come so that we can continue our journey learning from the best. Thank you so much, sir. Now we reached the end of our today's session. Before we part our ways, I would like to thank all the attendees on behalf of MTTF for joining us in this workshop. Your presence gives the meaning to this workshop. It is my sincere hope that you will be leaving today with a better understanding of MATLAB. Thank you all. We will see you guys at the same time tomorrow. Enjoy your day, stay safe, and let's meet up here again. Thank you all. Now we are leaving this meeting.